All right, ladies and gentlemen, welcome back. We're looking today into the kidney and how it regulates blood pressure. So a couple cartoons for you guys to get started once we get this up and going. I'm going to pick the best color ever for you guys. So there's no complaining, but there'll still be some complaining. So we're going to do just straight up black. Okay, how does that look? Can you see it? I know you can't answer me, but that's okay. All right, so we're going to be looking at a little bit of background information before I show you the cartoons. So these are the things that you have to know before we can understand the process. First of all, we know that water moves via osmosis. I don't know, that might be a little dark actually. We'll see. And it's going to go to where there's high concentrations of salt. So for example, if salt moves a certain way and moves from one area to the next, water is going to follow right behind it. The other thing is, in a vessel, if it increases in water, what that's going to do is it's going to increase the volume of that vessel. Okay? And if it increases the volume, it increases pressure. So these kind of concepts you should be able to understand before we move on. If not, pause it and take another peek at it. So here's a couple, oh, there you go. So here's a couple cartoons for you to get started. This one we'll be talking about a little bit more detail as we go on in this experiment, or sorry, in this podcast. So let's get going here. So the first thing you need to think about is blood pressure regulation, and it's all about aldosterone. And so what we need to know first is this thing called the juxtaglomerular. And what it is, it's the spot that's in between the afferent arteriole, the afferent arteriole, this is what we're looking at here, and then also between the distal convoluted tubule. So as you can see, even though if you're looking, this is the proximal convoluted tubule, goes through the loop of Henle and comes back up, right where it's finishing before it goes to the collecting duct, or before it goes down to the collecting duct, is the distal convoluted tubule. So this area here secretes a certain hormone, and that hormone is called renin. And that renin has a certain impact, which we're going to talk about in a minute. So this thing here is meant to help with low blood pressure. So in your vessel, if there's really low blood pressure, this will help. So these cells here are going to secrete this renin. What happens next is the renin is an enzyme that changes two things. So these two compounds, angiostensin, is basically an inactive version of this protein, angiotensin. Just like pepsinogen was an inactivated version of pepsin. So what this does is that this renin makes this thing active. And here's a little kind of unnecessary step, but I still need to tell you. This angiotensin is changed from one version to the next. You don't need to know what the versions look like. All you need to know is that angiotensin 1 is not going to be able to perform the function that angiotensin 2 is able to do. And angiotensin 2 stimulates the adrenal cortex, which is inside the adrenal gland on the top of the kidneys, to reduce or to release this hormone called aldosterone. So it's kind of a step-by-step process. So renin, which is secreted by the juxtaglomerular, and it causes angiotensin to be changed into angiotensin, I'll just put angio 1, which needs to be changed into angio 2. Why and how it happens, you don't need to know. It gets into a lot of biochemistry. And then finally, this angiotensin 2 stimulates the adrenal cortex to produce aldosterone. All right, and what does aldosterone do? That's a great question. It promotes the excretion of K+ and the reabsorption of sodium. So if we look, here's our blood, here's our little tubule. What's going to happen is sodium's going to get reabsorbed, and potassium is going to be excreted out into the tubules and eventually out as our urine. We know from the beginning there that if sodium is going in, what's going to follow directly after it is water. And what happens if there's more water? Well, more water is going to lead to more volume, and if it has more volume, it's going to have more blood pressure. So this is a way to have homeostasis take its place and create a higher blood pressure from this low pressure and make it equal again. Okay, so there's another mechanism here, and it's the complete opposite. So this is if you have high blood pressure. So if someone has high blood pressure, the hormone we're going to be dealing with is called atrial natriuretic hormone, ANH. And what it does is it's another hormone that regulates the amount of sodium, because that directly impacts the amount of water, which directly impacts the amount of volume, which directly impacts the amount of pressure. So this is secreted not by the kidneys, but actually by the right atrium of the heart. So here's what all hearts look like, not so much. So it's this one here. Even though it looks like your left, it's actually the right. So you're kind of like imagine yourself switching and going into the picture there. And this is in response to stretching. So what does stretching of the heart have to do with it? Well, if things are being stretched, it's because there's high pressure on it, and which is a direct result of the high volume. And so this is kind of a result of this high volume, and we want to make sure that we can bring that pressure back down. So what the ANH does is it inhibits the renin secretion by the juxtaglomerular. So what it does is it inhibits everything we just talked about. So what happens if there's no renin? What that does is it makes sure that the angiotensin can't be converted. It makes sure that the tensin can't be converted to 1 to 2, and it also means that the very end product, aldosterone, can't be released, which means that sodium's not going to be brought in, and if there's no sodium brought in, the extra water is not being brought in as well. So it just inhibits this part right where renin is secreted. Okay? So this promotes sodium excretion, natriuresis, which is the ANH. All right, so here is the juxtaglomerular apparatus. So you can take another peek at this. To be honest, I'm not sure why I just put that one in there. So let's talk about the last thing here, and this is called ADH. So this is the last hormone that we're going to be looking at. This also controls the amount of blood pressure, but it does it in a different way. It's not necessarily secreting it due to sugar. This one's directly related to the amount of permeability a membrane has due to water. So this ADH, this antidiuretic hormone, is released by the posterior pituitary, and as we know, things aren't made in the posterior pituitary, they're just the holding cell. So this one, as well as the oxytocin, is made by the hypothalamus, and it's meant to regulate the blood pressure like we were saying. So in the presence of ADH, what happens is the collecting duct, so that very end of the neuron, becomes more permeable, which means more water will leave the kidney and enter the blood, and that results in a concentrated urine, which means there's a lot of solutes in a minimum amount of water. So what it leads to is this higher blood pressure because more water can be brought into the blood. However, in the absence of ADH, what that does is it makes the collecting ducts less permeable to water. It basically blocks any of the channels that the water goes through, and since water is not leaving the kidney, it doesn't increase the blood pressure, and it leads to this dilute urine because more water is left behind in the kidney. So impacts on that, diuretics, so obviously the antidiuretic is what inhibits that. So what a diuretic does is it increases the flow of urine. So this is the last thing. It's nothing to do with blood pressure. This is just some impacts of the things we were talking about. So one of the impacts of diuretics, like alcohol, is it shuts off the ADH. So what happens is it causes larger urine volumes. Like we were saying, if ADH is shut off, it stops the permeability of water. So water's stuck in the kidneys and it gets excreted out. So that's why large amounts of urine will be secreted if people are consuming alcohol. And what happens when you secrete or excrete a large amount of water? People get dehydrated, and that dehydration is ultimately what a hangover is. Okay, your body's not able to function properly because they don't have hydrated cells. Other ones too, caffeine. This is what increases glomerular filtration. It decreases the tubular reabsorption of sodium. And the last one, there's also some dietetic drugs which also can help to inhibit active transport of sodium. So these diuretics can lower blood pressure because the sodium isn't being absorbed. So overall, what do you need to know? Just know the background info we talked about at the very beginning, and then also the 3 mechanisms of the hormones that regulate blood pressure. So I'd recommend going back, peeking at this again, and if you have any comments or questions, bring them up, and we're going to tackle this a bunch in class. So have yourself a fantastic night, and one more to leave you with.